behavior. Now let's look at end behavior. The end behavior of a polynomial function is the behavior of the graph of f of x as x approaches positive infinity or negative infinity. The degree and the leading coefficient of a polynomial function determine the end behavior of the graph. The leading coefficient is significant compared to the other coefficients in the function for the very large or very small numbers. So, the signs of the leading coefficient is sufficient to predict the end behavior of the function. To predict the end behavior of a polynomial function, first check whether the function is odd degree or even degree in the function and whether the leading coefficient is positive or negative. So, for even positive, an example is x squared. So for the left side of the function, as the function f of x approaches infinity, x approaches negative infinity. For the right side, as the function f of x approaches infinity, x approaches infinity. So for even negative, an example is negative x squared. For the left side of the function, f of x approaches negative infinity as x approaches negative infinity. For the right side, f of x approaches negative infinity as x approaches infinity. For odd positive, an example is x cubed. For the left side of the function, f of x approaches negative infinity as x approaches negative infinity. For the right side of the function, f of x approaches infinity as x approaches infinity. For odd negative, an example is negative x cubed. For the left side of the function, f of x approaches positive infinity as x approaches negative infinity. For the right side, f of x approaches negative infinity as x approaches infinity. What is multiplicity, you might ask? Multiplicity is a member of a multiset, which is the number of times it appears in the multiset. For example, the number of times a given polynomial equation has a root at a given point, or how many times a particular number is a zero for a given polynomial. Ways to find the multiplicity. Look at the function in factored form and determine different roots. Look at the exponent of each factor. This is the multiplicity of that root. Still, another way to describe it is multiplicity denotes the total number of times a value appears in a sum or set of variables. For example, the function x minus 2 squared plus x minus 3 squared. The total count of multiplicity in the above example is 4. We know this because the exponents add together to get 4.